Okay, this is section 2.4, question E64, and we're looking at SAT scores, which we are told are approximately normally distributed. We want to find the SAT score that would be a cutoff so that 20% of people would score above that score, 80% would score below. And we're given some information here about the mean and standard deviation. Notice that if we knew the z-score right away for the cutoff, then we could calculate the actual score right away, but we don't know the z-score that associates with this top 20%, and nor can we figure it out from this information we're given. So we need to go to the charts, and to do that we're going to have to go back to our other Wiley window. If we go to Read, Study, and Practice, and then the appendices, the statistical tables, we'll get this normal, standard normal probability table. Do be careful if you use a version of this online, like Googling it. Make sure that you're getting the same exact chart. See this shaded area right here is the probability that has a z-score at this level or lower than this. Other charts are set up differently where the reference is the median or something like that, which is fine, but just make sure you know what chart you're using. So in our case, we want this pink area to come all the way out to here. In other words, we want a cutoff score that is above 80% of the distribution of SAT scores. So we want our P to be 0.8. So we're going to have to zip down this chart here, and typically we're not going to find the exact thing, and we don't. We get this 0.7995 and 0.8023. So we're somewhere in between there. It's really not going to matter too much. If you just choose the closest one, you'll be fine. So this 0.7995 gives us a z-score. This is the tenths, and this is the 100ths. So we have 0.84 for our z-score. And just as a double check, 0.84 would be a little less than one standard deviation above the median, sorry. Or no, it is above the mean. So that is a good sign. So a positive z-score will always be above the mean, a negative will always be below the mean. So that seems reasonable if we want to be above 80% of the scores. So 0.84, and then we have to go back to our assignment here. And this is annoying, I realize. This is something that I've put in a complaint to Wiley about, but I doubt if it'll be changed during this semester, so for now we have to live with it. So we know that we have a z-score of 0.84 is what it was, and we have our mean, we have our standard deviation. So really, wrong window here we go. Pretty ugly here, but you can see the typical formula for standard normal, and so our z, as we found out, was 0.84. X is the specific score we're looking at, so we actually don't know that. And then our mean is 521 and a standard deviation 112. So 521 and then 112, and we're solving for x, so we'd multiply both sides by the 112, add 521, and that should give us roughly 615. There is a nice healthy tolerance on that one. So basically that's saying that if you get a 615 on the SAT math, that you're scoring higher than at least 80% of the people. You're scoring in the top 20% of those who take the exam.